So yes, Bipasha, first of all, please you introduce yourself.
Good evening, sir. Thank you for giving this opportunity. My name is P. Bipasha Pushti. I belong to Sagar, Madhya Pradesh, and I have completed my schooling from Sagar itself. I completed my bachelor's in mechanical engineering from IIT Devi Ahilya Vishwavidyalaya, Indore, and scored a CGPA of 8.43. I'm a fast learner, highly enthusiastic, and excited about contributing to Hpcl.
Okay. So what do you enjoy most about engineering?
So the problem solving skills. First of all, the problem solving thing and finding solutions to real world problems, and also using the in-depth knowledge which we have studied all through the engineering to find out to benefit the society as a whole.
So as you said, you are problem solving, right? Give me an example where you have solved a real life problem.
Real life problem. Like on the basis of engineering.
Yes.
Okay. So give me a few seconds.
Yes.
I remember it's like a very basic thing. So there was an overhead tank in my previous house. So we had to take out the water through it. So we kind of formed a siphon tube, which I studied in fluid mechanics by raising the height of the pipe.
Great. Great. Okay. So I can see that on your sweatshirt, that spirit is resilience. It's written there. Okay. What does it mean?
Spirit, I cannot read.
Spirit is resilience.
Okay, resilience is like
Resilience is an engineering word, is right?
Yes, it is engineering word in strength of materials, but in spirit resilience, basically it means that you are bombarded with setbacks and obstacles too many times and too many rejections, but you still come back. You still make a comeback with an optimistic mind.
Great, great. So what do you how can you differentiate between this resilience and toughness?
Resilience is the both are due to impact deformation, impact load. Resilience is about elastic deformation and toughness is about the plastic deformation. So resilience is up to the elastic limit, the area under stress strain diagram, and toughness is in the stress strain diagram, the whole area under the diagram.
So what do you understand by elasticity and plasticity?
Elasticity means when we're deforming a material, it returns back to the original state. But plasticity means that it gets deformed permanently.
It gets deformed permanently, right?
Correct.
Just draw a stress strain curve.
For a like ductile material?
Yes, ductile material. And the next question is, okay, just draw. I would like to one question from, I would like basically one answer. As a girl, what motivated you to pursue a career in mechanical engineering? As a girl, I have seen that there are many people, many students, many girls, basically they pursue computer science engineering, IT, electronics, electrical. What focused or what motivated you to pursue a career in mechanical engineering?
So throughout my academic journey, I've been drawn to these subjects like physics and maths, engineering subjects, and I found myself intrigued too much about how things work. So that's why I joined mechanical engineering. Another thing was that I enjoyed subjects very much. I loved the in-depth knowledge which I gained during the mechanical subjects. And even before joining the mechanical engineering, I searched and I researched a lot about the subjects. That's why I chose mechanical engineering. And the second thing, which I did not choose CS and IT, because in my 11th and 12th, I chose IP as my option. So I knew that I won't be able to survive in IT industry. That's why I chose mechanical.
Fine, fine. Okay. So have you drawn the curve?
Yes, sir.
Show me that.
Which
Just explain me that.
So shall I show you the points or
Yes.
just?
No, just explain me. I have seen that. Point A, point B, point C, point D fracture.
Till A point, it follows Hooke's law, and till B it is elastic limit. B is elastic limit. From B to C is strain hardening. So it is the movement of grain boundaries takes place in the strain hardening. This is followed during extrusion and extrusion and forging, strain hardening part. And the F is the fracture point, and C is the
What do you
maximum.
mean by extrusion and forging? What do you mean by extrusion and forging?
Extrusion is a constructive passage रहता है through which material is extruded. So there is a reduction in the area, that is extrusion, and forging is hammering a die on a material to get a deformed shape or whatever shape we need.
And what do you understand by casting?
Casting is a process in which molten metal is put into a mold and given a desired shape.
Desired shape, right?
Yeah.
So, are you aware of CNC machine? Have you ever visited in the lab CNC machine?
No, I have not visited CNC machine, but it was there.
You must have did the practicals in CNC machine, right? As a
No,
chemical,
sir.
as a chemical
No.
engineer, I have did, so you must have to did only.
No, sir, it was not in my curriculum.
Who said it's not there? In the practical, it's there.
Sorry, sir, it was not.
What do you mean by CNC machine? First of all, tell me. CNC stands for
computer numerical control.
Is it
Computer,
right?
It's somewhat right. The computer and numerical control is right. I think it's computer and aided numerical control. Sorry, sir, I don't exactly remember.
What is the use of CNC machine?
CNC machine is basically used for automation. Like we can put in the numerical values where we want the operation to be performed at.
Have you operated on lathe machine? Have you operated somewhere? No, didn't you? You didn't operate. What are the operations basically done in lathe machine?
It can be drilling. It can be
Tapering.
Taper.
Taper we don't do.
Taper we can't do on CNC.
Who said we can't do? Who said we can't do taper?
So, sir, sorry, sir, I have not heard about tapering on CNC machine.
What do you understand by taper? Taper, you know, no? The basically taper. Yes, right.
In a lens span.
So taper we can't do. We can.
No, sir.
We can do. इसलिए बोलते हैं कि प्रैक्टिकल अच्छे से करा जाओ. प्रैक्टिकल अच्छे से करा जाओ. आपका तो कॉलेज अच्छा था, आईटी डीएवी है ना. चलो, मूविंग टुवर्ड्स विच सब्जेक्ट? फ्लूइड मैकेनिक्स, राइट?
Yes, sir.
Tell me, how is basically velocity profile and shear stress profile in the case of pipe for laminar flow as well as turbulent flow? Draw the profile and show me.
Velocity and shear stress distribution.
Yes, yes. The very basic question I'm asking you.
Okay, sir.
We also study strength of material as a chemical engineer. Okay. Even engineering mechanics also we study, but it's not the syllabus in our GATE syllabus. That's why the people basically neglect, but I am well aware. एंड आपने कहा कि आपको लर्निंग अच्छा है, ये लर्निंग आपका गलत हो जाएगा, ठीक है, अगर मान लीजिए कुछ, समझे आप?
अच्छा, सर, फास्ट लर्नर पॉइंट.
हाँ, मतलब फास्ट लर्नर पॉइंट में जब जैसे प्रैक्टिकल एप्लीकेशन बोला ना आपने, ठीक है, वो मैंने पूछ लिया. ये किसके लिए बनाया आपने? लेमिनार के लिए. और टर्बुलेंट के लिए, टर्बुलेंट के लिए शियर स्ट्रेस प्रोफाइल बताओ. ये कौन सा प्रोफाइल है टर्बुलेंट के लिए? वेलोसिटी.
सो वेलोसिटी बनाया है मैंने.
हाँ.
और टर्बुलेंट शियर सेम ही रहेगा. थोड़ा सा.
एक मिनट, मुझे बताओ, लेमिनार सब लेयर और बफर लेयर में क्या होता है?
लैमिनार सब लेयर और बफर लेयर में the viscous forces dominate in the thin layer of the thin layer.
क्या वहाँ पे पोर्टे फ्लो आता है?
Yes,
Is
sir.
it a Cotte flow?
Co-ed flow.
Yes.
Co-ed flow is when one layer is still and the other layer is moving.
So in laminar, sublunar, buffer layer, is there a Cotte flow?
Yeah, somewhat we can say that it is a co-ed flow.
Yes, it's there.
Yes, somewhat we can say.
It's
Because
Cotte
the-
flow.
in the laminar layer, the viscous forces predominate. So yes, we can say that it is a co-ed flow.
Yes. I'm talking about turbulent, okay, not laminar.
Yes, and I'm also talking about turbulent because there is the co-ed flow can happen in turbulent
Okay.
only.
Tell me about the velocity profile, like it's parabolic or logarithmic?
In laminar, it is parabolic, but in turbulent, it is flatter due to turbulence and vigorous mixing.
Okay. So, sorry. The next question, coming to the next question, what are the assumptions of boundary layer theory?
Boundary layer. Give me a few seconds.
Yes. What are the assumptions?
That the fluid just near to the boundary is not moving, it is still.
Hmm.
There is the maximum shear stress.
Hmm.
And, no slip condition, the most important no slip condition.
Hmm.
That is fluid near the boundary is not moving. And
What are the boundary conditions what are the boundary conditions you will be taking?
in a boundary layer flow.
Yes, boundary layer theory. Yes.
That
What must be
99% of the in free stream velocity
at u
in
is
the
equals to at u is equals to 0. Sorry, at x equals to 0, u is
0.
at x equals to L, u is
0.99 times of u infinity free
fine.
stream velocity.
Two boundary conditions done.
Yes, sir.
That I have to tell you. Third boundary condition, tell me.
Du by dy at the bound x equals to 0 would be 0.
At x equals to L, shear stress is equals
Shear,
to
um, shear stress will be 0 at x equals to L.
shear stress will be 0.
Yes, sir. Shear stress will be maximum at the
Center.
boundary.
At the center.
Center will be 0.
At the center will be 0.
Yes, sir.
You in the before point you said that shear stress will be 0 uh, at the 1 minute.
At the
Not at the center. At the x equals to L. You said that.
So x equals, I'm assuming that x equals to L means the center.
At x equals to L center कैसे हो गया? कैसे होगा center at x equals to L? बताना पड़ेगा.
About a boundary layer flow on a flat plate.
मैं फ्लैट प्लेट की बात कर रहा हूँ, है ना? बट स्टिल आपने पूछना था कि सर आप किसके बारे में बात कर रहे हैं, आप फ्लैट प्लेट के बारे में बात कर रहे हैं या फिर आप पाइप के बारे में बात कर रहे हैं? आपने पूछना चाहिए था. ठीक, वो आपने पूछा नहीं, वो बहुत बड़ी गलती करी. ठीक है, ये लो आपका ये है ना? अब बताओ मेरे को, इसमें बाउंड्री कंडीशन पहली वाली तो हो गई एट एक्स इक्वल्स टू 0, ये आपका एल है.
So these are two parallel plates, na?
यस, टू पैरेलल प्लेट्स.
Okay, sir.
बताओ.
So shear stress will be 0 in the middle. At x equals to L by 2, shear stress will be 0.
L/2 पे
Shear stress will be 0.
ठीक है, और रेट ऑफ शेयर स्ट्रेस का बताओ.
Rate of shear stress at the center.
हाँ,
That will also.
रेट ऑफ शेयर स्ट्रेस कहाँ पे 0 होगा?
So it will. So sorry, sir, I'm not sure.
ये कहाँ पे 0 होगा? होगा भी या नहीं होगा?
D tau by dt.
चलो, नो प्रॉब्लम, फाइन. जस्ट ब्रश अप समवॉट नॉलेज, बाकी तो सब बढ़िया है. ठीक है, प्रेजेंटेशन स्किल बहुत अच्छा है. कम्युनिकेशन स्किल काफी अच्छा है, बस कहीं पे फंसाने की कोशिश किया मैंने, फंसे गए, थोड़ा सा फंसे। प्रैक्टिकल एप्लीकेशन, जब से आपने बोला कि आई एम कीन ईगर टू लर्न, लर्निंग इज द न्यू थिंग, इसलिए मैं आपको प्रैक्टिकल एप्लीकेशंस पे लेके जा सकते हैं, है ना। ये पॉइंट नोट करिएगा जो मैंने बोला अभी, जो जो मॉक लिया, ठीक है, ये एग्जैक्ट मॉक था एचपीसीएल का,
Yes, sir.
है ना, एग्जैक्ट। ना ये, ना इससे ऊपर जाएगा ना इससे नीचे आएगा, इससे ठीक एग्जैक्ट मॉक, क्लियर है। तो
Yes, sir.
होप आप अच्छा करेंगे, मुझे आशा है कि आपका सिलेक्शन, व्हाट इज द मार्क्स, मार्क्स ऑफ स्कोर?
114
114, चांसेस कैटेगरी
OBC.
ओबीसी, चांसेस है, चांसेस है आपका अच्छा है, ठीक है। तो सिलेक्शन चाहिए मुझे, है ना, फाइन, ऑल द बेस्ट फॉर योर इंटरव्यूज, कोई डाउट होता है तो मुझे कनेक्ट